encryption. So encryption is supported in vSAN, and it works just fine with compression and deduplication. So if you enable everything, that's going to be a very busy backend environment. So if you have deduplication, compression, encryption, everything enabled, data will be encrypted once it hits the cache here. When it arrives at the cache, it's going to be encrypted. Then when it's moved from the cache to the capacity, we will decrypt the data, deduplicate it, compress it, encrypt it, and write it to the capacity tier. So all of that is possible. We have two forms of encryption. So first one is data in transit encryption, and second one is data at rest. So let's talk about data in transit first. Data in transit means that we will encrypt the data when the data is moving or is moved between different hosts. So when the data is traversing the network, we will encrypt it. The objective, of course, here is to protect the environment against attacks like man in the middle, where someone tries to get access to the network and steal some data and reconstruct it and read its content. So that's how encryption is comes to play here in the form of data in transit. So data in transit will be possible by basically letting each one of the hosts create an encryption key and use that key to encrypt the data. Okay? So each host will create an encryption key, use that encryption key to encrypt the data before sending it through the network. That's data in transit. So the two options are completely independent from each other. You can enable any of the two or both. There is no relationship between the two. So that's data in transit. Okay. Next, we have data at rest. Data at rest will encrypt the data when the data is written to the vSAN data store. And this can protect against types of attacks where someone tries to maybe remove some physical disks from the host and try to read their content. They will not be able to do that because everything will be encrypted. Data at rest will require something called a KMS, a key management server. It doesn't really work the same as data in transit. Data in transit does not require any KMS server. The keys are generated by the hosts themselves. For data at rest, we need a key management server. A key management server is actually a server that needs to be configured somewhere. It must be configured to provide, as the name indicates, encryption keys management functionality. Starting from vSAN 7 update 3, VMware introduced a native KMS server to vSphere environments or vSAN environments. Before that, there was a requirement to have an external KMS server. So what do I mean by an external KMS server? It's simply a solution that you purchase separately. There are many vendors that can provide a KMS server solution. Encryption is not limited to vSAN only. There are many solutions that can require a KMS server. Some applications for encrypting the data, databases, and stuff like that. They require a KMS server. So you can get a KMS server from different vendors. And Dell EMC is one of them. We have a product called CloudLink. I'm not sure if it's still available or not. So a KMS server is an external KMS server is actually a solution that you deploy, and you can use it with any application or solution that requires KMS server, including vSAN. So since the introduction of the native KMS server, there is some customers are just wondering which one to use, which option do I need to use. Is it enough to use the native KMS server, or should I go with an external one? The answer is very simple. If you don't have any requirement in your environment to use a KMS server, I mean, if you don't have any other application that requires encryption other than vSAN, the native KMS is okay. Just keep in mind that the native KMS works only in the vSphere environment. You can't use it with anything else. If you go with the KMS, the external one, that's going to add a lot of interesting features compared to the native one. So first of all, the external EMS can be used with anything, not exclusive to vSAN. Most of the KMS providers will provide clustering functionality with their solutions. So this means you're going to have to deploy multiple KMS servers. They will be configured in a clustering environment. So if one goes down, you can have backup and stuff like that. And of course, the KMS external one can be used not only with vSAN but also with anything that requires a KMS. And typically, it's going to provide more features than the native one. But again, it requires more effort because it needs to be deployed separately. It needs to be purchased. There is a cost that comes with it. The native one is included and it's available for free. Okay. So how do we add? For the full list, of course, of supported KMS servers, you have a couple of links here. As we have seen, there are. You see, this is a link to docs.vmware.com. Here you have how to set up standard key provider, how to add a native key provider. This is the PDF file with the list of supported KMS servers. Basically, the KMS server is configured at the level of vCenter. So you need to select your vCenter, configure key providers, and you click on Add. So before version 7 update 3, there used to be only one option. Now, as you can see, we have Add Native Key Provider and Add a Standard Key Provider. If you go with the native, the native will only ask you to provide a name. And if you have hosts with a TPM chip, which is a piece of hardware that is used to store offline encryption keys, it's not mandatory, just recommended. So you just need to select Use Key Provider only with TPM protected hosts. So you're just going to ignore hosts without TPM. If you don't have TPMs, do not select this option. So you just give it a name and click on Add Key Provider. Next, you're going to need to back up the key before starting using the native key provider. If you select the standard key provider, which is external, it should have already been deployed. And when you deploy a KMS server, for example, in the form of a VM, that VM must not use vSAN as the main storage. You're not going to deploy a server into a storage you are planning to encrypt. Doesn't make any sense. Okay, so for the external KMS, you need to give it a name, provide the IP address, the port, and a few additional settings, and then click on Add a Key Provider. After that, excuse me, you need to establish trust to secure the communication link between vCenter and your KMS server. Once the KMS server is added, then you can enable data at rest encryption, okay? And this can be done by, again, going to vSAN services. You select your cluster, configure, okay, vSAN services, and from here you have encryption. So you have data at rest and data in transit. Again, a good practice is to enable data at rest in the first beginning, because it's also an option that will basically prepare the disks by reformatting the disks. So they can, in vSAN, and this is not covered in this class, but basically the disks will be reformatted using a disk format. There are different versions, and sometimes vSAN will basically apply the required version based on your needs. If you need to go beyond that version because you need encryption or something else, the disk reformat must be reapplied, and that will require evacuation of the data. It happens also not only when enabling deduplication or compression, but also when you enable data at rest encryption. So make sure to enable this in the first beginning. Here you can see when you enable data at rest encryption, you need to select the key provider, the default one, and you have an option here called wipe residual data. If you have an environment with some data already written into it, at the moment you enable encryption, anything written after enabling the encryption will be encrypted, but everything that existed before in your vSAN data store will not. So if you want to start with from scratch and having everything encrypted, you can select this option. It's going to simply delete everything in your data store, and you can guarantee that everything is encrypted. Data in transit can be enabled from here. All you need to do is to enable it and select Rekey interval. As explained before, each host must create an encryption key that's going to be used to encrypt the data while it's traversing the network. And that key will be by default generated every 24 hours or once a day. You can reduce or increase this value. So if you select more than 1 day, 3 days and 7 days, this will consume less resources because each time the host needs to create a key, it's going to go back to its main CPU and say, hey, I need an encryption key. Those are some resources used from each host. So if you increase this value to 3 or 7 days, this will use less resources, but your environment will be more put at risk because, well, a key will stay there for 7 days. That's too much. If you decrease this value to 12 hours or 6 hours, this will generate more keys more frequently, and your environment will be more secure, but that's going to consume more resources. If you don't want to select any of these options, you can go with custom and introduce or add a number in minutes. You have to choose between 30 to 10,080 minutes. So half an hour or 3 days. So the value that you're going to use here will depend on the policy of your organization, security policy, of course.